and thanks to Arequipa and to Ernesto, I'm in love with Peru. Well, you notice that my talk won't be in Spanish. I'm working my Spanish, but it's still not enough to give a talk in Spanish. So it's going to be in English, unless you want me to do it in French. That would be really great. So my talk is titled XML Disambiguation. This work, I'm conducting it with, not alone, with a lot of colleagues and students. I put some names over there that you can see, just to let you know that I can see here a lot of students, and in our research life, we rely a lot on students, so you can be part of what we're doing about the future. Just let me give you some hints about where I'm coming from. I'm coming from France. You notice that we are here, and I'm here somewhere. And my university is located not far from Spain. We are 20 minutes from San Sebastian in Spain. And my university is divided over different distant sites, different campus. And mine is related to Anglet and Bayonne that you can see over here. We are just here. Our research group is named LUPA, and we are 33 faculty members, 8 professors and 25 associate professors. We have some technicians, and we have more than 23 PhD students. I would like to increase this number of students, especially from Peru. To give you a flavor about my city, I put here some photos so you can see how it is, and I believe that you will like it. Ernesto liked it when he came and visited me some month ago, and I'm sure that you will as well. Okay, now I'm gonna go through the introduction of my presentation. Well, this talk I'm gonna try to convince you that there are some issues related to XML disambiguation, because we usually think that when we talk about XML it's sort of technology. But still, I'm gonna try to describe with you the disambiguation techniques that we used to do, and show you what are their drawbacks, limitations, and I will also discuss the ongoing challenges and possible directions that you can conduct. Well, all of us know maybe about the web technologies, but I would like to make things clearer. So the web started with static pages, and now we're moving to digital world. When I talk about static pages, I mean HTML files, HTML pages. When we used to write the address of the web pages to discover and display the content. So the user at that time was just a consumer of some static information. I remember I used to create and develop HTML files, and I was really happy to see the result. Well, things evolved and into different steps. The second step is the web applications, where we have dynamic information. So we're going to use in this second generation some databases where we stock the data, and the content of the web changes according to the queries. And the user also here is a consumer, but the data or the information is dynamic. The third generation is the web services, where the user can request some information from the server, and the server must be able to answer the query even if locally doesn't have all the information. So using the web services technology, the user is able to be satisfied in a faster way. And the user can be a server provider or requester at the same time, because everyone can create web services. And the fourth generation is the digital world, and this is something that we are preparing. We're talking now about Internet of Things, internet of the web, and everything will be connected somehow. So your car will be connected, your fridge will be connected, your bike will be connected, everything is connected. Of course, we're not there yet, but it doesn't mean that we don't need to prepare this digital future together. And in this future, I just wanted to emphasize on the fact that XML is still there, because this is the standard that we are adopting on the web. I also want to share some definitions with you. Well, I don't know if you are familiar with those. Let's talk about data. Data is the lowest abstraction of data representation and contains no meaning. If I give you this example, if I say 2001 or 2010, without saying anything about this, it has no meaning. It is useless. However, when we talk about information, information means something. It's like when I say 2001 is the year of something related to the semantic web. I cannot read my slides here, but you can read them all there. Okay? So it's the year of announcement of the web semantic. When we talk about metadata, metadata means data about data. Well, when we say data about data, I can say that in different terms. I can say, if I give a date, I can tell I'm going to give who is giving the date, who created the date, and so on and so forth. So we are describing the data by other data. And the last thing I should define with you is the knowledge, which is combining all this together. Which means I put data, information, metadata, and I mix them together so we can come up with what we call knowledge. Okay? And we say that we are using knowledge base in order to represent the knowledge we're having. And usually, to represent the knowledge, we're going to use some descriptions or languages. And usually in those definitions or representation models, we're going to use different terminologies like T-box, when we are talking about the structure of the information, and we talk about A-box, when we talk about the instance of the information. I give you here a schema about this, where you can see some entities here, 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 here. You can see some connections, some link between them to define what kind of relationship they can have. And you can see here an instance which is an A-box related to some information. So I just wanted to make things clear before I start talking about the disambiguation. I hope that now you could understand and follow in a better way my next slides. Well, as I told you, now we are moving towards a digital world. Much more data. We are talking more and more about the big data. So we have more data. Some are structured, some are not. And now we are trying to have data about data in order to associate information with more meanings. And the idea is to, since we are having XML standard that has been adopted on the web, the idea is how we can enrich XML so we can have more semantic-based information. And now we are moving towards what we call the semantic web. And if I give you the building blocks of the semantic web, well, this is not my figure. This is the figure of the semantic web provided by W3C. You can see here that the XML is really there, and it's representing the basic of everything. It is the basis of RDF, which is the semantic web technology, OWL, OL, and so on and so forth. So, I don't know if you are familiar with XML. I just want also to make things clear. Well, XML means extensible markup language, and it can be observed at this file. It's a textual file where you have some tags, like I'm showing here. You have academy, faculty, department, and you have also some values inside. And also you can have attributes. And this is a way of observing XML file. We can also observe an XML file as a tree. We call that a rotate ordered label tree, like I'm showing you here, where you're going to order the tags or the elements according to their appearance in the file. And sometimes you can consider the values or not. When we don't consider the values, we talk about structure-based only. When we consider the values, like John here, like, I don't see that value, sorry, John Kramer, John Tagagi, we talk about structure and content-based, okay? So we have different views of XML. We have what we call document-centric view, which is a sort of document with some labels in it, like the one I'm putting here. This is what we mainly have on the web. And in addition to that, you have more structured view, which is called data-centric view, in which you have more structures, more labels, so to allow you to have better understanding of what you are putting in. I hope that it's clear for you now. So, what I used to do for the last 15 years, I used to try to compare documents together. So, let me just share with you some of my scenario. So, imagine you want to compare the three documents here. You have three documents, A, B, and C, and you want to see how far, to which extent they are similar to each other. So, if you want to compare them using classical techniques, well, it will be hard to say, because in a way or another, they are close to each other. But one is, let me say, two are more closer to the other two. Like if I say maybe the document B is closer to A than the document C. If you understand what I'm saying, because college is closer to academia than factory. But if you want to do this, you have to consider the meaning of the labels. And when we started working on that, and actually we discovered that existing techniques used to use graph techniques to compare things without considering the semantics. And this was our main issue at that moment. I'm saying 15 years back. So what we did is that we proposed some framework in which we transferred the documents into some representation, internal representation, for documents and for grammars as well. And from those representations, we were capable of comparing documents together, comparing documents and grammars, comparing grammars together, so to have some similarity measures, so to be able to rank the documents or the grammars. But also we were able to do some alignment to say this document is similar to this one according to those elements, because we were using what we call a distance that we extended in this work. And what we did in this general framework is that we applied it into different areas, and we publish it in different areas as well. So here I listed some of them. So you can see that we proposed this framework to compare user profiles on social networks. So using the same thing, we adapted, of course, the distance that we were using, and we did some nice works to allow people to compare their profiles only. We also did some nice work related to RSS. I don't know if you are familiar with this with this technology, which allows you to send some feeds to some participants. In this work, we created some algebra, and we were able to create the relations that we could have between some subset of elements using the framework. We also use it to compare geographical data, sorry, and we did it also using multimedia data. And recently we published something related to SVG files here in 2014. And we also did it for web services. Maybe I can talk about it later on. The idea was, instead of sending the messages between web services as a whole, What we used to do is that we used to compare some parts of the of the messages, and we were just using, we were just sending the different parts, not all the parts, in order to optimize the broadcasting of some messages, using the measures that we were proposing in the frame. Well, this is what I was doing for the last 15 years. But now we are having a motivation which is related to this scenario. Imagine we are having those two different documents, totally different, they don't share anything, no structure, nothing. And you want to compare them. When you apply our technique, okay, we'll have a good result, a good measure, but still not enough, because our consideration of the semantic or the meaning that we have was not good enough. So if you want to compare those two documents, honestly, as a human beings, you can understand that they are representing exactly the same information. But if you ask the machines to do that, they won't be able to do it. Okay? So this is actually related to what we call the ambiguity of tags. Because each tag can have different meanings. Like if you take the tag star here, itself, it could mean different things. Okay? It could mean celestial body, it could mean champion, it could mean hotel ranking, and so on and so forth. And I can say the same thing for direct, right? So, since we're having different meanings, if you want to compare, you have to consider this in a nice way. So, the problem is how we're going to resolve the semantic ambiguity, since each tag name or each value can have different meanings, or one word can have some sub-definitions of it, sub-meanings, let me say it like this. So it's not that easy. But if we were capable of doing that, what are the benefits? The benefits are many. I would like to share some of them with you. If you wanna imagine you are capable of injecting semantic into your comparison, you will be able, in different scenarios, in different applications, to do better. Like if you take data warehousing, you will be able to manage in a better way the changes and the versions, because you can be able to detect in a finer way those things. You can also be able to monitor the changes. You can be able to archive not everything, but you can select the new things, not necessarily using the same terms. If you take the data integration, it's the same thing. If you want to integrate two data sources, well, it's easier if you have a good similarity measure to do that in a semantic way. Like this, your integration will be better and more appropriate. The same is true also for classification and clustering. And particularly, let me say it is true also for information retrieval. Actually, the database community, where I'm coming from, proposed several languages for XML, let me say it like this. But those languages are mainly adopting exact matching, so there's no semantic in them. So providing those languages with some semantic measures will allow you to do better, will allow you to do what we call the semantic information retrieval or concept-based retrieval. So instead of just sending words, we are capable of sending concepts as queries, so we could have, as a result, whether the documents or their concepts. And we can also do that to enrich the metadata of the data we are having. I told you about the web services. This is exactly what we could imagine. If we have better semantic measures, we could improve maybe, let me talk about the SOAP protocol, which is what web services are exchanging, so to transfer the information. If you are capable of regrouping messages and just sending the common parts to all, or to one, or to different parts, that will allow you to use the network in a better way. And it's also true if you are using WESL, which is the language that we are using to describe web services. If you have the semantic included there, you can you can discover in a better way, you can recommend in a better way, and also you can compose the web services in a better way. Of course, this is still true if we are talking about social and semantic web. I mentioned here something related to social matching and semantics. The social network analysis will allow you to disambiguate entities in the social network, and also identifying the semantic relationships that they can have according to what they published. And if I talk about social semantic information retrieval here, this can be very useful if we are doing indexing, query formulation, rewriting, ranking, or also presenting the result. When we use semantic, this is something that we are working on in my group recently. We can also detect in a better way events. When I say events, it means maybe this presentation. It could be also this event, which is the conference, or it could be my visit to Arequipa today, which would be a personal event. And using the semantic, we will be able to link in a better way resources, since we will be able to detect the meanings of why this resource is linked to another. So with those applications, I hope that I convinced you that there is a need to have a better understanding of disambiguation. So let's now go through the background. Why XML disambiguation? Initially, a lot of work have been done in information retrieval area, and we used to call that word sense disambiguation. And the aim of word sense disambiguation was to automatically identify the meaning that the author was trying to inject in the text, which goes beyond the techniques that we used to do in text mining, like lexical pattern discovery or syntactic dependency, and so on and so forth. So when we talk about word sense disambiguation, just keep in mind that we're talking about 5 main elements. Let me share this with you. The first one is selecting words for disambiguation. The second one is identifying and representing context, using references, referencing knowledge sources, associating senses with words, and the last one is evaluating the semantic similarity between senses. I'm gonna detail each one of them so you can have better understanding of all this. The first one is how to select words for disambiguation. So you can decide about what are the terms, like you can detect them individually, or you can say, I'm gonna scan everything and I'm gonna disambiguate all the words in a document. So those are the 2 main approaches that we used to do. All words or lexical sampling. In the all words, I disambiguate everything. Well, this is good because I will consider everything, but it is costly. And because, processing everything is not like processing just words. And in existing techniques, we ignore semantics. While in lexical sample, we will consider some parts, as I said, and that will be faster, of course. The problem is also that in existing techniques, we also ignore semantic ambiguity. I put here some references if you want to go through that about a survey about word sense disambiguation published in ACM computing surveys. This is the first step in word sense disambiguation. The second step I was talking about is identifying the word context. If I give you a word, what is its context? It has a very important impact on the next steps. So let us define what does the context mean. The context of a word in traditional flat textual data usually consists of a set of terms in the word's vicinity. It means the set of terms occurring around this word within a certain predefined window size. Okay? So once we're having the words for disambiguation, we need to identify the context, and once we do that, we have to decide how we will represent them. So usually we have two approaches. The first one is value of words. I put them as a set of words, ignoring about their position within the documents. I don't care. I put them there and I've tried to process without any consideration. And the second one is vector-based. I put them within a space, and then I will try to find some values according to this space and according to the words I'm having here. The third step is using reference knowledge base, because when we want to disambiguate semantically, we need to have some reference, because automatically we cannot do that without any reference. So we have two families, two categories. The first one is corpus-based, where we're going to use some learning techniques so to come up with identifying the senses. So we'll label some categories manually, and we will try to do to detect the other meanings automatically. Well, this is good because it is automatic, but there are some drawbacks there. The corpus-based approach is generally data hungry because we need data to learn, and sometimes we don't come up with the really true understanding of the words, because it is based on the documents we are processing. Okay? So in order to cope with this, we are using another approach, another family called predefined knowledge base, where we manually create that and we handle everything manually. I don't know if you are familiar with WordNet. This is a very famous knowledge base that we usually use for general purpose applications, but I put here others like Roger, Devise, and Anglet. The interesting thing is that, well, it takes some time to prepare the knowledge base, but once it is there, it is useful because you can rely on it. And recently, the predefined knowledge base approaches were receiving much more attention than the corpus base. Once we know what kind of knowledge base we are using, the next step is how to associate senses to words. And to do that, usually, we will use two techniques, supervised and unsupervised. Supervised, I'm going to use some training sets, training data, and from the training data, I will come up with the rules to be used to associate senses to words. With unsupervised, I'm going to use some measures that will allow me automatically to see if a concept is related to a word or not. And in order to do this estimation, actually we will use different measures. I will share with you some of them here. The first one is edge-based. So according to the knowledge base we are using, which usually is defined as a tree, we can estimate the similarity between two terms or two concepts using the shortest path between them. And here I put the formula, but the idea of the formula is to find the first common ancestor that they share and then use it in your similarity measure. This is the edge-based measure. You have another one called node-based, where you will inject into it not only the structure but also the information content here, using some analysis automatically or manually. I also put here the commonly used formula to detect information content node-based value. The third approach is called gloss-based, where you can try to see the overlapping between the concepts and their senses. The gloss means the definition of the concept, because usually in the knowledge bases we need to define them, and this is what we usually. So what we're gonna do is that we're gonna take the definition of those concepts and the concepts, and we'll try to see if there are some overlaps between them. And according to the overlapping they have, we're gonna score them. So if I want to sum up this, I can come up with this, this scheme here, where you can see that the first step, the best thing to do is lexical sample. So not to process everything, just select the right terms. I will come back to this point later. For context representation, the best choice is to use vector-based because tag of words we lose some information. When I talk about external information sources, the knowledge base is better because where we can rely on it, it's not like the corpus base. The word sense matching, unsupervised because we want things to be automatic without human intervention. And the last one, semantic similarity measures, we observe that the close-based approach provides better results. That's why I put it there. So now I just recalled the background within this area. Now I want to just show you what's happening within XML disambiguation. And then we'll take some lessons from all this. So let's go back to those points that I was presenting. The first one is selecting words for disambiguation. We observed that existing approaches, current approaches, adopt the all words disambiguation strategy. So they don't select, they choose all the terms to be disambiguated. So it comes up to something like this, which is complex. The second one is context identification. Well, actually what's happening is that within XML context, we didn't come up with a unified definition of what we mean by a context. So what people try to do is to come up with some approaches to solve the problem of context identification. So let me share some of them with you. So I'm going to talk about 4 of them. The first one is parent node context, where we, with the authors, I listed the references over there. I don't know if you can see. Created what they call canonical tree, in which they include just the leaf and the parent together. And according to my example, I show you here what I mean by canonical trees. So here, for title, director, year, and center and picture, I'm going to put them in one CT. I'm going to do the same thing for cast and star, and for CT here, it's alone. And in this approach, the authors, they didn't consider the values. If I take the second one, which is root path context, I will consider for each node its path to the root. And here I give you the list of all the values of the nodes and their context root path, according to the same example I was giving you from the beginning of my talk. And here neither we don't consider, the author didn't consider the values. The third one is subtree context, where here we're going to take the node and it is subordinates. And here I'm going to show you for the same, always for the same example, what it gives here for each element here. This one and the biggest one. So parent, root, and subtree. And the last one is crossable edge context. This one is the most complex one because the authors of this approach decided to give a score to the edges that we can use. That's why they called it crossable edge context, using this fantastic formula that I'm not going to explain to you. The idea here is just to assign a different weight to some nodes and to the edges according to the direction that you are using. And according to the experiments that the authors have been conducting, they obtain better results. Well, this is what I was wanted to tell you about context XML identification. About representation of the context, most of the approaches in XML use bag of words. Like you have a term and you consider a window around the term without thinking about if it is relevant or not. So So once we do that, as I said before, we lose the structure and we lose some information. Only one approach in existing solutions, define that as a vector-based, as I said before, by having some assumptions to assign some weights to the nodes. I'm not going to detail that, just keep that in mind, that we can have a vector-based, but to distinguish and to assign the values of your space to some measures, you have to give some values. So here, they provided some values according to some assumptions, like when a node is closer to another one, it will impact it in a bigger way. Once you do the context representation, the last, before the last one is you will need to associate the senses to XML nodes. And for this, within XML umbrella, we have two approaches. The concept-based, I don't know if you can read here either. I have the tree, and from the context I defined, I will try to identify the senses of all the terms. I will try to map them to the knowledge base, and after I will try to find all the combinations, and I will select the most similar ones with the maximum similarity values. The context-based is a bit different. I will start with the node without its context. I will try to define the senses of the node. And once I do that, I will map it to my knowledge base. And once I do that, I will try to compare that to the context I already detected. And I will select the most similar ones. And like this, I will associate the senses to ambiguous terms. Now, once you do that, you need to evaluate. So how we used to do it. I'm going to tell you about that according to three perspectives: methods, measures, and data. So for the methods, we can see the disambiguation methods from two perspectives as well: standalone and end-to-end. When I say standalone, I mean when the tester evaluates the quality of the disambiguation process separately. And when I say end-to-end, it means that the tester will try to demonstrate whether the disambiguation helps to improve the performance of the application in terms of maybe data search, classification, clustering, and so on and so forth. So this is the first thing that you have to keep in mind. The second one is the measures that you will use. Well, first measure efficiency, effectiveness, sorry. Effectiveness, which is related to the quality of your disambiguation. Usually we used to use precision and recall. And I don't know if you are familiar with that. And we can use their harmonic mean as value in order to combine them. But also, concerning disambiguation, we can also consider the coverage, which measures the percentage of XML nodes in the test document for which the system provides a sense assignment over the total number of assignments that should have been provided by the system. Well, the coverage is behaving better than the F value. Concerning efficiency, well, actually, we have a problem because existing solutions do not provide complexity analysis, do not compare the result to existing results, which is a problem. So there's a need to do something about that. The last point is related to data. Well, with XML-based test data, we notice that for future evaluation and studies, you can use some online data sets. If you want to really do that, I listed here some data set that you can use. One is DBLP, another one is IEEE. You have PubMed, which is a collection of data medical documents, Reuters for information, and so on and so forth. And I display here their characteristics, so you can, if you decide to do disambiguation, to test according to different scenarios. And all this drive me to the following comparative analysis. I don't know if you can read neither. Well, existing solutions, as I said, they adopt for node selection all works. Concerning the XML data, most of them use the structure only while ignoring the values, ignoring the content. Concerning the context model, they use different ones, as you can see here, since we're not having one unified definition. The representation of the context was done mainly by sets, as I said before. The window size of the context is mostly fixed, unless in the last one, which is related to ask the user to give some very complex parameters. So it is good because we can tune the application, but if we want to ask some non-expert user, it's very hard to do. So there's a problem of complexity to give those values. And most of them are using knowledge-based external information, which is, as I said before, attracting more and more. And all of them are using unsupervised word sense matching techniques. And I wanted to say something about evaluation method. No comparison between them. This is what I put here. So they try to do a disambiguation for individually without comparing what they are doing, if they are behaving better than others or not. Well, this drives me to now to tell you about what I see as ongoing challenges. Well, I can see some, but I'm sure I'm not. It's not set complete what I'm saying, because the more I think about it, the more I found new challenges. So I listed some of them here. Evaluating semantic ambiguity. Like, let me share this with you. If you wanna, you will go for a lexical sample. Like the first step, what are the words that you have to disambiguate? It's a bit tricky, because how your algorithm will select the words. What are the assumptions that you need to consider? Where to start? It's complex as well, because imagine if you take a term which relies to another ambiguous term. So where you start? You start from the first one, the second one. So there's some dependency that you have to solve before. How you will evaluate? Well, here I listed some assumptions that I think they are good, but well, maybe there are others that we need to consider as well. Like the number of node label senses. The more senses a node has, the more ambiguous it is, right? The node structural position and depth with regard to the root of the document. Like if we are, the closer we are to the root, the more ambiguous we are, right? The number of children node having distinct labels. Here I added some animation just to show you. Like if you have two terms, picture, and in picture you have 5 sub-elements, title, and the other one with different titles, different elements. Well, of course, the first one is more ambiguous than the second one, right? So those are the assumptions that you need to keep in mind, but maybe you can think about others. Second challenge relating to the structural context. How to fix the size of your XML context? Manually, automatically? Can we use learning to do that? Well, up to now I said that XML documents are considered as tree, but actually they are not. Because if I want to be really honest with you, in XML documents you can add some links. And once you add links, there is no tree anymore. We're talking about graph here. So if you want to consider the links, how you solve the problem of links? How you will solve them? What kind of representation will take? So it makes things much more complex. How to extend context representation? Well, up to now, bag of words, vector. Maybe we can think about other things like maybe matrix-based. I don't know. How to select the best nodes. Imagine you decided about the window. What are the nodes that you need to consider within the window? Maybe you need to do some selection. Okay, I still have 5 minutes. Okay, good. Thank you. Do you need to take 5 range, like range query to do that, or you can consider more KNN-based things? I don't know. Combining structure and content, like sometimes, as you notice that most of the techniques, they are based on the structure while ignoring the values. But if you put the values, that will maybe help, and maybe will make things much more complicated. Because how you will detect entities, how you detect resources in general, let me say it like this, and how you will consider the types, because each type might have a different way to compare it. Handling tag names. Actually, we are using the same pre-processing techniques to evaluate tag names, but actually this is not correct, this is not good, because the tag names, usually, when we are considering one tag, there is no need to pre-process it. It's straightforward almost. Most of the times that we are having 2 terms, they are connected with a dash. So usually when we pre-process them, we will consider them as separate words. So we eliminate probably some good concept, and this is bad as well. So we need also to adapt this technique, our technique for the pre-processing. Okay, using unconventional knowledge base, because I think that if you want to solve the problem of knowledge base, because actually we are doing that manually, can we do that collaboratively using what we are having like Wikipedia, Google, Yahoo, or even the social networks? How we can do that? How we can do that and in a way that could be reliable? Okay, I'm not going to talk about this. This is something important, how to involve the user, but not to ask him to do things complicated, because the user cannot be expert. What's the window size? He doesn't know, or she doesn't know. So how he can tune it and allow the machine to tune in an automatic way other parameters. So this is something also that we can work on. And reducing complexity, working on it, this is not easy. I believe that there are some things to be done relating to indexing, validation of the knowledge, because this is the bottleneck of disambiguation. And maybe we can think about some semi-structured parallel processing architectures to do that. Just to tell you that, of course, what I showed you is just a survey of what's existing, but we've been working on some solutions, and those solutions we already published some of them recently in those 2 conferences, EDBT and ER, which is held now in Stockholm. I just wanted to say that because Regina, which you can see the name here, and Irvin and Renato, they are students of San Pablo Catholic University. And I met them the first time I came here, and I would like to thank again Ernesto for the opportunity. So they are co-authoring this work with me, and I'm sure that others will be glad also to join. Thank you very much. I just take this opportunity to invite you to visit my city. The next year we are organizing this the International ASEAN Conference on Computational and Collective Intelligence in Digital Ecosystem in October. I hope that you can submit and attend. I will be glad to receive you there. Thank you very much.